Hello everybody, I would like to welcome you to our 19th video in the pre-algebra playlist, and in this video we are going to introduce you to the concept of decimals. Now before I begin with the conceptual understanding of the decimal, I would like to show you a few examples of what decimals look like. A decimal consists of three parts. In the first part, there is the integer number. In the second part, there is the decimal point itself. And then there is a third portion, which consists of numbers after the decimal point. 1.21 is an example of a decimal. It contains of the integer number, then it contains of the decimal point, and then it contains numbers after the decimal point. Another example of a decimal is 3.1806. Now there is no restriction to the number of numbers after the decimal points. It can go on for about 1 digit, 2 digit, or it can go on like this forever. So now let's go over how to read decimals, as in how would you read this besides 1.21. The integer portion of the decimal is read just as you have read it so far. Then the decimal point is read as the word and the numbers that are after the decimal points are read as follows. The first number has a place value of tenths. The second number has a place value of hundredths. The third number has a place value of thousandths. And the fourth number has a place value of 10,000ths. Now this pattern continues on forever, and it goes on for however many numbers you have after the decimal point. So the fifth number would be the 100,000th, and so on and so on. Now let's do a few examples where we convert the actual decimal number into its appropriate word sentence. So in this first example, let's say you wanted to convert the number 1.96 into its appropriate word sentence. So the first thing that we need to do is refer back to the last page and read the integer portion of this decimal number as we would normally. So the integer portion of this decimal number is anything that is to the left of the decimal point. In this case, the only number left to the decimal point is the number 1. And then we would include the word and to symbolize that we are now going to deal with the numbers that are to the right of the decimal point. Now the next thing that we need to do is figure out how many numbers there are after the decimal point. In this case, we have one number after the decimal point and we have the second number after the decimal point. So there are two numbers after the decimal point. We know, referring back to the last page, that the second number after the decimal point has the place value of the hundredths. Now the only thing left for us to do is figure out how many hundredths there are. In this case, we have 96 hundredths. So we write this as 96 hundredths. So let's go over it one more time. We have the integer number 1, which is right over here. Then we use the word and to symbolize the decimal point over here. And then we figure out the number of numbers after the decimal points. In this case, we have two numbers, the 9 and the 6, after the decimal point. So we know that the most we will use is the hundredths. And then lastly, we figure out how many hundredths we have. In this case, we have 96 hundredths. So 1.96 is appropriately read as 1 and 96 hundredths. In this example, let's say I have the number 21.012. The first thing that we need to do is figure out how to write the integer portion of this decimal number. In this case, we have the integer 21 because 21 is to the left of the decimal point. So we write down 21 like this over here. Now that we are done with the integer portion of this decimal, we need to represent the decimal point by the word and. Next, we need to figure out how many numbers there are after the decimal point. In this case, we have the number 0, the number 1, and the number 2. So we have three numbers that are after the decimal point. In this case, we won't be using hundredths, but we will be using the tenths, the hundredths, and the thousandths. So the highest number that we will be using is the thousandths. The last thing we need to figure out is how many thousands we have. In this case, we have the number 012 after the decimal point. 012 is the same thing as saying 12. So we read 21.012 as 21 and 12 thousandths. In this example, let's say we have the number 129.3. The first thing that we need to do is write down the integer portion of this decimal number into words. So we have the integer 129, which is more commonly known as 129. The next thing that we need to do is symbolize that we are dealing with a decimal point by using the word and. Next, we need to figure out how many numbers there are after the decimal point. In this case, we only have one number, which is the number 3, after the decimal point. So in this case, we are going to be dealing with the tenths. Lastly, we need to figure out how many tenths we have. The number after the decimal point is only the number 3. So we are dealing with 3 tenths. So we read 129.3 as 129 and 3 tenths. So in this example, let's say you have the word sentence representing a decimal, something such as 32 and 1,234 ten thousandths. Now, if this seems really complicated to you, let's just take it step by step. What we need to do first is figure out what the integer portion of the decimal we are dealing with is. In this case, we can easily identify the integer as the number 32 because that is the representation given in words before the word and, which represents the decimal point. So 32 is written like this right here. Then we include the decimal point to represent the word and. Then we figure out how many numbers we will be dealing with after the decimal point. In this case, we are given that we have 10 thousandths. So the first number after the decimal point is the tenths, the second is the hundredths, third is the thousands, and the fourth one is the 10 thousandths. So we know that we will have 4 numbers after the decimal points. Now all we need to do is figure out what numbers will be put on these 4 blanks. So what we need to do is convert 1,234 into number. So the 1,000 tells me that I have 1 in the thousands place. The 200 tells me that I have a 2 in the hundreds place. And the 34 tells me that the last 2 numbers will be 3 and 4. So all I need to do is put these 4 numbers into these 4 respective blanks. So I have 1, 2, 3, and 4. Finally, my answer to 32 and 1,234 ten thousandths represented as a numerical answer is simply 32.1234. If you don't feel like you need to know the conceptual meaning of decimals, then feel free to skip on to the next video where we go over how to add and subtract the decimals. Now you encounter decimals pretty much every time you go to a big grocery store or pretty much anywhere out there where you have to make a purchase. So let's say you go to some place such as Taco Bell or Subway. Most of the times you will see your total as being a decimal. So if you have something such as your total being $31.52, now what this means is that your total is in between the numbers 31 and 32. What this tells me is that my total is not just 31 and it's not just 32, but it is 0.52 more than the number 31. So in this case, 31.52 can be represented as 31 plus 0.52. Now, when it comes to money, the lowest denomination in the United States is known as a penny, or basically 1 cent. Now, 100 cents make a dollar. So if you have something such as 3 cents, you can represent that as 0.03. This is the same thing as saying 300ths of a dollar. So basically, if you have 99 cents, that is represented as the number 0.99. Now, if you add 1 more cent to it, that is the same thing as saying $1 because every 100 cents is equal to $1. Now, different decimals and different place values of decimals are used in different cases. For example, if you're dealing with the conversion between meters and kilometers, you have 1,000 meters equaling 1 kilometer. So what this really tells me that if I have something such as 2.521 kilometers of some sort of a distance, then this is the same thing as saying 2 kilometers plus additional of 0.521 kilometers. Now 0.521 kilometers is pretty much the same thing as saying 521 meters because every 1,000 meters makes up a kilometer. And 2 kilometers is the same thing as saying 2 times 1,000 meters. So 2.521 kilometers is the same thing as saying 2,000 meters plus 521 meters to give me a total of 2,521 meters. So pretty much the best way to think about decimals is that it is a portion of a whole. When you're dealing with things in the real world, or pretty much any time in your math textbook you're given an example, most of the times you won't be dealing with perfect integers. Many times you will have a portion that is more than some integer and some portion that is less than the next big integer. And that is where decimals come in place. Decimals are useful to represent portions of the whole, especially when that portion is in between two integers. In this case, the number 2.521 is bigger than the integer 2, but at the same time, 2.521 is smaller than the integer 3. So that is how you would use decimals, and that's the conceptual understanding of decimals. So I hope you learned a lot from this video, and in the next video we're going to go over adding and subtracting decimals. So I hope you keep on working hard, and I'll see you in the next video.